A1 VEX Robotics by Rebecca Skoukas. I have selected this technology for a closer analysis as it will be introduced to our school this spring along with a high school tech teacher and his students. What is VEX Robotics? Well, it is designed to be used as a robotics platform for classrooms of intermediate students and higher to create and build robots. Students can simply begin building with VEX Robotics, as it's an all-plastic, toolless construction system allowing students to quickly snap together pieces and build their creations. As a teacher, robotics easily fits into their curriculum. It taps directly into STEM, science, technology, engineering, and math. And for BC teachers, it follows along with the now included ADST field, Applied Design Skills and Technology subject. Teachers will find this technology highlights both robotics and computational thinking, as it gives the opportunity for students to perform visual programming for any robot they have created. Some of the pros. Use with this technology allows students to have practice with hands-on construction activities, practice their skills in mechanics, critical thinking, collaboration, and career skills. They can observe their robot, troubleshoot any problems, and try again until successful, with many different components involved such as structure, motion, sensors, programming, and manipulations. It allows for all types of students to hone in on their desired interest. Software incorporated with this particular VEX Robotics program is free. The mod kit runs in your browser, so that means you don't need to install software, allowing easy access for students and teachers to incorporate into the classroom using existing technology. VEX Robotics includes an iPad application that allows students to program their creations from anywhere. Students can input codes and then immediately watch their device follow through with their commands. Learning this text-based C programming software gives students the practice they need to naturally graduate onto more advanced projects or careers. A positive effect. Using robotics in the classroom has shown to increase engagement in students' willingness to engage, collaborate, and continue to work on an idea for as long as it takes to become successful at the task at hand. Using robotics also allows teachers to carry out problem-based learning, as students are asked to carry out a specific task once they're given a robotics kit along with the coding software. An example may include program your vehicle to drive in a square. VEX Robotics hosts competitions. They offer competitions where students form teams and compete designing and building a robot that can play against other teams in engineering challenges. These challenges occur at the local level, and then successful teams can move on to national challenges. Each year, VEX hosts world competitions in April. There are a couple different challenges. A teamwork challenge where two teams try to maximize their score. A robotic skills challenge in which one robot and one driver play against the clock to complete a skill. And a programming skills challenge. One robot uses sensors to run autonomously as the robot has been pre-programmed using software from a laptop or mobile device. Some of the cons. The actual sets are expensive. One robotics kit is approximately $400, tax included. The drawback is these kits are best served for students to work in groups of 3. In this way, students are able to collaborate together with enough ideas to solve challenges, but at the same time have a small enough group so each person has a task to carry out. Therefore, there's a total cost of approximately $4,000 to $5,000 to have enough kits for a class of 30 students. For students to have ongoing progression with their designs, kits need to be assigned to one class, as it's not conducive to try and share, as that would mean disassembly of their creations. So it's limited to use of one class of students for any given time period when the goal is to build a robotic device or vehicle. With over 850 pieces in one kit, there will be some lost pieces as kits are used multiple times with different classes, and many of the pieces are smaller than a dime. What else is out there? LEGO Mindstorms NXT has robotic kits and software. Essentially, both LEGO Mindstorms and VEX Robotic systems are very similar. They both have the capacity to give teachers enough tools for their students to build a robot and then work on the additional attachments. A benefit of LEGO Mindstorm is that its rechargeable battery can be charged while still on the robot, or you can use 6 AA batteries, whereas the VEX IQ Brain is powered solely by a rechargeable battery and will need to be recharged when not in use. LEGO Mindstorm has a total of 8 different input-outputs, whereas VEX IQ has 12, giving more choice of components. VEX IQ also includes a touch LED sensor, giving the ability to switch the output color. LEGO Mindstorm costs 30% more than VEX IQ. However, their software has been found to be very easy to use and intuitive for students. Looking at the educational potential, VEX Robotics permits students to use real-life computer coding language and test out their programming in real-life scenarios, as they can actually manipulate the robot from their device. Unlike computer coding applications such as Scratch, where students can only play back their inputs on the screen and share them with the click of a button, giving students the opportunity to manipulate the robot from a device entices them to troubleshoot or change their set of directions in order to get the desired outcome. These types of robots do include recognition software, so that this allows them to problem solve when approaching obstacles. Robotics goes hand in hand with recognition software, and as that technology is enhanced, it will build upon a robot's ability to become familiar with many types of objects, such as people. Eventually, these VEX robots could recognize certain people and perform commands when prompted. Robots are becoming more involved in our daily life, as many cars now use recognition software to parallel park, and many fast food restaurants have components that use automation for repeated tasks. Having students more familiar with these machines can help give them a tactile advantage when dealing with them in the workforce and in everyday life, so they can better understand the world they live in.